All right, so Foundations of Math 26.2. In this section, we're exploring graphs of linear systems. Okay, so linear systems, systems of linear inequalities, really, too. So graphs of linear systems, and we should put inequality systems. Okay, so that's I'll add that to the title. So that's in the title in your textbook as well. So what is a linear system or a system of linear inequalities? There is such a thing as a system of linear equations, which I'm not sure if you've done that yet or not, or if that's a different class. I think that's a different class. I don't think you guys have been through that yet. But the system of linear inequalities, first of all, a system is a set of two or more. Okay? So we're talking about a system. We're talking about more than just one thing. There's other things that are happening at the same time. And what two or more of what? Well, linear inequalities, just like we've been working with the 6.1. They are graphed on the same coordinate plane. Okay. The intersection, that also means the overlap, okay, and I'll just write that word down here, overlap, of their solution regions, so that is the shaded regions, where both shaded regions overlap, represents the solution set, okay, so the set of solutions for the entire system. Okay, so we've been working with, in 6.1, we've been working with, just a single inequality and shading the region. Well, now it's just a small addition here, and as you look at the in summary and the key ideas in your textbook there, it's on page 307, if you want to go there. Here's a picture of one. You see that? So we have a line right here, okay, and this is y is greater than x. So y equals x is this red line. So let's see, is 0, 6, is that in this solution set, 0, 6? Well, 0 would be x and 6 would be y. So it looks like this is the shaded region for the red up here. Okay, where the y values are larger than the x values. Everybody see that? That's the first one. Now the second one, the second equation on here is, what is it? Y is less than or equal to 5. Okay, so this is the graph of y equals 5 right here. And so if the y value has to be less than 5, we're talking about 4, 2, 0, 2, negative. So that's this one. You see that? So let's go back to the first one, which is right here. And you can see there is a section, and I'll maybe zoom in for you just a little bit here. There is a section that overlaps. And so it's kind of from here, above this line, and below the y equals 5. So it's this one here. You see that? That's the region where they overlap. And of course, it probably would be also forever to the left here and down a little bit too, right? So you gotta get the picture? Where the two regions overlap, that's the solution set for the system. Okay? Any questions on that right now? Okay. So this, you shade this in when it's XER, YER. That means that if X is an element of all real numbers, that means positive, negative, 0, decimals, irrational numbers, everything, then you shade it in. So every conceivable little decimal number is involved. If it's whole numbers or integers or natural numbers, like down here is whole numbers, you have to be a little more careful. Okay? If one of them is all real numbers and the other one is just whole numbers, let's say, then you can't shade everything, and the solutions would be just the dots that represent the whole numbers or whatever. So you have to watch for that as well. These ones are both whole numbers. You can shade the region, but make sure that you specify that only the whole number solutions that are in that region would be possible solutions. Okay? All right. So let's do a little example here with two inequalities on the same graph. So write these down. Let's do this as our example. Okay. Okay. Okay, so graph the, and remember we talked the other day about this term, feasible region? That just means the region, and feasible means it's doable, kind of like it can, feasible means, yeah, that's doable, that works, okay, that works. And so it's the region that works for both inequalities, okay? All right, so everything is the same as we've already done, we just have to do it twice on the same graph. That's really it. And we'll say that this is x ER and y ER, okay? So we'll just shade everything, we won't have to worry about dots or anything like that, okay? All right, so x plus y is less than or equal to 20. Well, what we need to do is make that an equation. So let's do that, x plus y equals 20. And remember, this is going to represent the boundary, right? So x plus y equals 20. This one's pretty easy to change into y equals mx plus b, so why don't we do that? We'll just get y all by itself. That one's really easy to do. Why? Because this is your y-intercept, remember that? So let's go 20, here is a y-intercept right there. And then what's the slope of the line? You look at this term right here, what's the slope? Anybody remember that? Shout it out if you know. -1, right? Because this -1 is the coefficient here, very good. Yeah. Okay, so that means we go down 1 over 1, down 1 over 1, down 1 over 1, or down 20 and over what?
20.
Right on. So down 20 and over 20, so let's put a 20 there. All right, so this is an less than or equal to, so the equal to is what I'm interested in right now. So I'm going to draw this line here, if I can. Use this function here, make that as straight as possible. Okay, we'll just make sure that goes through 20 if we can on both sides. That's as close as I'm going to get. All right. Okay, so there's a line. It's going to be solid because it's equal. All right. Now I need to find out which side I should shade, right? So what's a quick point that you can quickly test? 0, 0, right? The line doesn't go through 0, 0, so always check 0, 0 if you can, because honestly, it's the easiest. Why is it the easiest? Because this is 0, this is 0. I mean, they're gone. It's just 0. So then you can think of, is 0 less than or equal to 20? Is that true? Yes, it is. Okay. Now, you can shade right now, and I would totally encourage that. When there's a lot of, like, okay, so in the future, you're going to be doing systems with more than 2. There's going to be 4, 5. So if you start shading everything right away, you're going to have a lot of shading, and it's going to be tough to figure out which region has been shaded twice, which region has been shaded 4 times. Do you understand what I'm saying? So this is something new that I will encourage you to start practicing when you have systems. And this is what I do. I started this line, and I just put little arrows like this, saying that the region is on this side of the line. Okay? And that's because I don't want to shade 4 or 5 times in the future and then kind of wonder, okay, right? So this just tells me that the feasible region is kind of under or to the left of this line. So I would encourage you to do arrows. If you want to shade, go ahead. There's only 2. It should work just fine. I'm going to use arrows. So let's do, in a bit of a quicker fashion here, let's do the other one as well. Okay? Okay, so we're going to make this is going to be y equals x plus 5, right? That's the corresponding equation. And again, that's going to be the boundary for the second inequality. So we have 5. Okay, so let's see. If this is 20, this would be 10, this would be 5. There's 5. And the slope is positive 1. So that means I'm going to go up 1 and over 1, or up 15 and over 15. That make sense? So if that's about 15, let's put that point over there. Up 15 over 15, up 5 over 5, right? All that. So another line here. Let's see, where's my fancy line tool? Okay. See if I can get these through those points. Not quite, but I'll adjust. Ooh, that looks pretty good. Sweet. Okay, so that's my second line. If that was red, that would be even better. I think I can make it red. Pen properties. Red. Okay. Sweet. Okay. So that's the red one. I could make the other one blue. Here, give me a second. I think this is important. Let's make this blue. Not purple. Blue. There we go. Okay. Blue. You can do purple when you're a teacher someday, okay? But I'm just going to do blue too. School colors too. Yes, question?
I don't know if it's just me, but could you change all the black ones to blue?
Can I change all the black ones to blue?
All
the black arrows?
All the arrows. It's
It's going to take me forever, man.
Change the line to black.
Oh, well, you can do that.
Yeah, I'll keep the arrows. I get what you're saying, but I'll keep the arrows. Okay. But I will do, I'll do black arrows here on this one too. Okay, so which one, which side is going to satisfy this inequality? Again, let's pick 0, 0. It's pretty easy, right? So this is gone, this is 0. So 0 plus 5. 5 is less than 0. Is that true? No, it's not true. So 0, 0 is not in the feasible region. Okay, so here's our black arrows again. See what I'm doing? Going this way. And this, trust me, is going to be a little bit easier to see where the feasible region is. Because look at, these arrows are facing up this way. These arrows are facing kind of down to the side this way. So our feasible region is, we're ready to now shade. Our feasible region is here. Everybody see that? Okay, and then you shade kind of over as far as you want there. But that's the feasible region. So we can determine which points would work for this system and which wouldn't. So let's see. Let's test one just to make sure we've got it, okay? So this is 0, 5, that's this point, and this is 0, 20. So what's a point that's on the axis that's somewhere in between? 0, 15, okay? So that's going to be over here, right about here. So 0, 15, okay. So let's test 0, 15 to see if it works for both inequalities. So the first one is going to be 0 plus 15 is less than or equal to 20. 15 is less than or equal to 20. Does that work? Absolutely. Let's go to the next one. 0 plus 5 is less than or equal to, y is 15. So 5 is less than or equal to 15. Does that work? Yeah, that works. So we've picked a point in what we've determined to be the feasible region, and it works. Okay? So any questions about this? Because this is what you're going to need to be able to do here. 6.2, 6.3 is kind of a combined lesson here. Any questions about that? Okay, so here's question number 1, 6.2. And again, it's just exploring systems. So right now, what this question is asking us to do is to, for each system, describe what you can infer from the graph about the restrictions on the domain and range. Okay. So this is not a matching, it's just they're asking you about the systems here themselves. So let's just make sure that this equation matches with this system, okay? Because that's important to know. I mean, I thought this could have been a matching question as well, but that doesn't look like it is. But anyways, so y is greater than or equal to negative 2x. Okay, so the equation that would be the boundary would be this. Y is equal to negative 2x. So is y equals negative 2x one of these lines, do you think? Okay, well, we have an intercept of 0. You see that? And so one of the lines has an intercept of 0. And we should have a slope of negative 2. So that means the slope is going to go down from left to right. And we would go down, if we went down 2, we should go over 1. Right? Negative 2 over 1 is the same as negative 2. So down 2 over 1. It appears to be this line right here. This one. Okay? So that's good. The second one is now. Okay. We can change it to y equals, and I think that's usually a little bit easier, but let's write the equation. So negative 3 equals x minus y. Let's take the y to the other side to make it positive. And we'll take the negative 3 to the other side to make it positive, to get y by itself. So this is going to be y equals x plus 3. Again, I'm just doing a couple steps at once there, isolating for y and making it positive. Okay? So you can do that in however many steps you want. But the boundary here should be y equals 1x plus 3. And so plus 3 is our intercept, which looks true for this line. And the slope should be 1. Okay? So this is, let's see, going from this point here, we go 1 over 1. Up 1, over 1, up 1 over 1. That seems to work. Okay? And so yes, this is matched with this equation, with this system. Now the overlapped regions, really quickly here, with the 0, 0, 1, okay? Let's test a point that's over here, like 2, 2, okay? So 2, 2, 2. So negative 2 times 2, and this is positive 2. So 2 is greater than or equal to negative 4. Is that true? 2 is greater than or equal to negative 4? Yeah, a positive number is always bigger than a negative 1. So this is going to be in the feasible region. That's great. Arrows here. Okay. This one over here, let's choose, it looks like this was shaded down here, so let's just check it. Let's go negative 2, negative 2. Let's check this point. So negative 2 here, minus a negative 2. So this is going to be negative 3 should be less than negative 2 minus negative 2. What's that?
0.
0, thank you. Yes, not negative 4, because it's minus a negative. So is this true? Negative 3 is less than 0. Yeah, it is. Yeah, a negative number is less than 0. So for this line, this is what we have. See the arrows? So where the arrows overlap would be this darker region right here, and that's all good. It's all true. Okay, so what can we infer about the graph? Okay, so look at the shaded region, okay? It's all filled in, all shaded completely. Is there anything we can say about X and R, the domain and the range? Anything you can say about that? Go ahead and shout it out if you think you know. What could we say about X and R? John? You were shaking, you nodding your head there earlier.
X should be greater than or equal to negative 1. Isn't that?
X should be greater than or equal to negative 1?
Yeah.
Okay, that's okay. Well, X greater than or equal to negative 1. Well, if X was negative 1 and Y was positive 1, that wouldn't quite work.
Oh.
But that's a good guess, okay? That's a good guess. What I'm looking for is the nature of the domain and range. Okay, so the domain is the possible values for X. Okay, and actually I find in high school a lot of students don't do well with domain and range for some reason. I think maybe it just hasn't been brought up enough. It's not maybe as repeated in the curriculum as it should be. But domain, all possible values of X. Range, all possible values of Y. Or domain, all possible input values for some kind of situation. And range is all possible output values. Okay? So what can we say about the range or the restrictions? So for this one, because it's all shaded, there's no dots or anything like that, the domain is X is an element of all real numbers. And the range, Y is an element of all real numbers. Okay? X and Y. Okay? Because over here, you see this, we won't match them, but you see how there's some dots here, right? Okay? There's some dots in here. So it's not necessarily the case, it looks like, that it's XER. Can we tell anything about these two graphs here? Or let's take a look at this one. There's dots here. So what does that mean? Probably what? Well, these are whole numbers, but they're negative, right? So it looks like the X, the Y values here, the vertical ones, are dots. So it looks like they have to be integers. And the X values are also dots. Negative ones are good, right? So this looks to be like the domain is X is an element of integers, and the range is an element of integers. You see how the dots are there? Okay, so for C here, there was a question about whole numbers. Okay, whole numbers don't have any negatives allowed in the solution set. So there are negative numbers here. The dots are on the negative side, so that's okay. So this one here we have dots again. I guess the question would be, are we allowed positive numbers, negative numbers, for both X and Y? So is this going to be whole numbers? Could it be natural numbers or integers, right? So let's see. Domain. X is an element of, what do you think? The x values. Okay, so we look left and right. I see a bunch of positive x values. I also see some negative x values up here. You see that? So this, I guess, can be integers. It's not shaded like number 1, so it's not all real numbers. So what about the range? Okay, what about the range? So the range is y values. Now the feasible region is here. You see? That's the feasible region there. So we don't know if any negative y values are allowed. We don't really know that. So I would say that you could say it's possible that the range could be y is an element of only, could be only natural numbers, could be only whole numbers, but what we do know for sure is that it's not just all real numbers. Okay? So I would be okay with the range could be whole numbers, could be natural numbers, but just to be safe, we say that it could be integers. We know for sure it's not all real numbers. Okay? Because again, the feasible region is not down here, so we don't really know. We can't tell from this graph if they're allowed or not for the y. Okay, so that's 6.2. 6.3 is about creating these systems from word problems, so we'll get into that here